Hi, my name is Andy Mallet, and this is Glimmer DSL for SWT tutorial number 23. So last time I covered a sample that was related to Canvas graphics. It was called Hello Canvas Drag and Drop. Today I'm going to cover another sample that uses Canvas graphics. In fact, it's an elaborate sample. It's the game of life. So before I get started, I'm gonna talk a little bit about what the rules of Game of Life are. So let's visit the Wikipedia page. And there it is. And this is how the Game of Life looks like. As you can see, there's a bunch of squares or pixels that are moving all around the screen. And they actually move according to some rules. So let's get into what the rules are. So these are the four basic rules. Basically, any live cell usually a live cell will look black and a dead cell is white. So anything that's black here is a live cell, and anything that's white is a dead cell. And as you can see, it's a grid, and it's a grid of cells horizontally and vertically. So any live cell with fewer than 2 live neighbors dies, as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 live neighbors dies, as if by overpopulation. And finally, any dead cell with exactly 3 live neighbors becomes a live cell, as if by reproduction. So to give you a better view of the Game of Life, here it is. It's zoomed in over here. And you can see that the black cells are kind of moving. What's really happening is some black cells are dying, and then there are white cells that are living in their place. So how do we implement this using Glimmer DSL for SWT? So let's get into the sample and launch it and show you a working version of it. So there it is. As you can see, I have a blank slate for the grid, so I can just click with the mouse like this and make some random, selections of live cells. And then I can click step to step into the next generation. So with every click of step, it'll calculate for every cell whether it should die or live, and it'll display it on the screen. So as you can see, it looks like cells are dying and living, and it gives you the illusion that they're moving. And however, you could hit the play button, and that will give us an animated version of it. There you go. Now we have a version that looks just like the one on Wikipedia. And sometimes you end up with stable structures that will either oscillate indefinitely or will just stabilize. So if I were to stop this, clear it, and do something else, hit play. I just wanted to show you that I have a speed button here that helps me accelerate or decelerate. And then as you can see, we have a bunch of cells that stabilized. They remained alive forever, basically, unless I stop and kind of mess with them a bit, like do this, do that. Let's see if that will affect them. Yeah, they got affected. So how is this built? So let's drag this to the left side and get into the code. The key thing is that before body, so we have a Game of Life, which is a custom window, custom shell. The body of the GUI, the graphical user interface is here, but before I get into that, before body gets executed beforehand to set up some data, and we have a grid, and this is the grid of the Game of Life, and it's a model, and it's got a width and height of 20 by 20. So before I get into that, let's look at the model. So I'm gonna open the model over here and show you the grid. This is the grid. It's got a row count, a column count. The key thing in it is it's got cell rows. So it's got rows and rows and rows of cells, and every row is consisted of a number of cells. So it will, if you have a column count of a row count of 20, that means you have 20 cell rows, and for every cell row, you will have 20 columns for a column count of 20. So it's a two-dimensional array. cell rows, and that contains the data. And then I have a step method that lets you step into the next generation. You can play so that it animates regularly, and it does so using multi-threading. And then you have a stop that will stop it from animating. And then here's the cell. Every cell can be alive or dead, so it's got an attribute of alive that gives you the aliveness of the cell. There are some convenience methods like live, die, so you can see how they're implemented, and then toggle aliveness, which will just flip the aliveness. Step will calculate what will happen to this based on its neighbors. So yeah, and in fact, step is what's delegated to by step over here. There it is. But in fact, this was built test first for the models, because as you can see, the model algorithm for Game of Life is a bit of, it has very specific rules, so it can benefit from writing tests, unit tests. So I have unit tests that check what happens when you live, when you die, but the key thing is when you step into the next generation. Okay, here I say, live cell with fewer than 2 live neighbors, it dies. It dies, etc. And then I have a test for with 2 to 3 live neighbors. And then with 4 or more live neighbors. So with this one, it's supposed to remain alive. With this one, it's supposed to not be alive anymore. And with this one, if it was a dead cell, it becomes alive if it had 3 live neighbors. So now let's jump into the GUI. So the GUI body is basically, you have this window, meaning a shell in SWT, and it's got a canvas widget, so it's this white part. And it's simply, I'm representing it exactly the way I'm thinking about it. It's a canvas of pixels, and then basically I'm building rectangles for every cell. Every rectangle has a cell width and a cell height. That doesn't matter so much. What matters really is the height and width of the grid, so meaning how many cells horizontally and vertically I have. So I have 20 by 20. And then I'm using data binding over here. So for every rectangle, the background color of it could be black or white. And I data bind that to, so I'm using this 2-dimensional array on grid to grab the row index and column index for every cell. Data bind to the alive attribute on it, and based on that, if it's alive, I make the color black. If it's not, I make it white. So it's very simple code. It perfectly maps to the way we think about it, so it's highly maintainable. And here I'm just adding some listeners. So on mouse down, I toggle aliveness, meaning if I click here, it switches aliveness, and if I click it again, it toggles it again back to dead. I want to detect if I'm dragging. So right now I'm dragging the mouse, and if I drag, it'll basically detect dragging. And then here, if I'm dragging on mouse move, it'll basically make every cell alive. It's just a convenient way of making me draw a sort of a shape in basically live cells, and then be able to hit the play button and see it, get into action as far as living and dying. So that's pretty much it for the canvas. It's very straightforward. The composite at the bottom has the step button, the clear button, and the play button. The play button can change text depending on stop, or depending on the playing attribute of grid, whether it's playing or not. And it's relying on data binding again for that. So it's very simple. And I mean, these are cases of unidirectional data binding. Usually we use data bidirectional, but this is a case where the button text, I cannot change the button text from the GUI, but the model can change it for me, so it's unidirectional. Same here for enablement. Like as you can see, when I play, those buttons get disabled, so it's unidirectional data binding. They're just doing the negation of the playing attributes. Finally, here I have a scale widget, which you might have not seen before. That gives me this sort of a sliding scale for slower or faster speeds, and is simply hooking into the speed attribute on grid. And by doing that, you affect how fast the grid is making changes. And when you step into the grid or you play it, you toggle playback, it'll basically automatically update the alive value on its cells. And when they get updated, this data binding over here will automatically reflect the changes in the view. So I don't have any code that is manually doing that work. It's all happening automatically for me when I hit the play button, for example, or when I hit step. So that pretty much covers everything about the game of life. If you want to learn more about Glimmer DSL for SWT, check out the GitHub repository.